Great. Though Mr. Hickam loves New York City, it has a rat problem. Yes, it does. Let me tell you, ever been, you'll see those rats everywhere, especially in the subway. Let's pretend that Mr. Hickam won the lottery. I wish. And bought an abandoned building in New York City with plans to turn into a new home. However, he couldn't do that for 1 year. So my buddy Will went and went to my property and noticed there were a few rats in this abandoned space. Will started counting up and recording how many rats were in there each month for me. Here's Will's chart below. If the rats continue breeding at this rate, how many will there be in this building when I finally start to turn into my new home in 12 months? So in 12 months, I'm going to go up there. How many rats are going to be in there? Okay. Because there's nobody exterminating these guys. So here's my chart. When I first started 0 months, we had 8. Then in 1 month, went up to 14. So they're going bigger and bigger and bigger. Well, that to me says, hey, you probably got a little exponential growth here, don't you? These guys are growing very quickly. And as the time goes on, they're going to grow more and more. Here it only went up a little bit, a little bit. Boy, it's starting to almost double. So we want our equation. We know it's going to be A times B to the X, right? Exponential growth. So let's go to Desmos, plot this, and find the curve of best fit. So here it is. I went in, I made the table. To do a table, you hit the plus key and then hit table and add the numbers in. I already did it to save us time. We can see here on the graph, here it is right here. And it is growing very quickly. Okay. And you can see a little curvature in that line. So I want to get the curve of best fit that fits my data here. So I'm going to click right here in 2, and I'm going to type in the equation. I'm going to say y. Now I need to say you're reading my data. So I then hit 1, and it puts it y sub 1. So it knows, hey, we're reading your data, right? And I'm like, yes. So I then need to put my little squiggly to say approximately, what is it? It's not quite equal. Don't put an equal. Put the little squiggly there and say, hey, we're going to approximate the equation here. And I then say A times, I'm going to go back to the multiplication, multiply by B. So I come back into the alphabet. B raised to. So I need to raise it to a power. That's right here, this AB button. And I'm going to raise it to the X. Now I need to say sub 1 to say, look at my data. You will see here now that it says, hey, there's a very good, see, it's almost hitting all those points perfectly. And my R squared value says, hey, this is a very good set of data here. It's almost a perfect 1. It tells me my A value is about an 8.1 and then about a 1.79. So we have about an 8.1. So our equation, if we come back to do the equation, y equals, okay. So I needed my A value 8.1. 8.1 goes here times what was my B? I got to keep looking back and forth. My brain does not remember. 1.79, let's say. 1.79 raised to whatever power. That equation tells us how many rats are going to be whenever we want to know. Well, when did I want that X? What did I say? I want to do it in what? 12 months. So I'm just going to type in 8.1 times 1.79 to the 12th. Now let's see what it calculated. Now remember, I've rounded my numbers here, so it's not going to be exact. So we have 8.1 times 1.79 raised to the 12th. My calculator says 8764 about. 8,764. Huh? That's a lot of rats. Yeah, we definitely want to start controlling those because it grows out of control. And that is what happens in big cities if they don't try to go in and get rid of some of them. Now, there's the answer. That answer is fine. Again, it's been rounded, so it's a little off. If I go back to Desmos, though, what I can do is I can come in here and I want to draw a line right at 12 and see where it intersects this other line that's been created. So all I'm going to do is simply create a vertical line at X equals, 12. And then if I scroll, let's see where the two lines intersect. And we can see it's way, way, way up here. I got to get even further because we said it was like 8,000 something, right? This is going to give us a little bit of a better, if we can ever even get in here. Well, they're almost At this point, they're almost right on top. We should see a point of intersection. And again, this is taking forever, so half of you have probably left me, which I don't blame you. Just like my girlfriends in 6th grade, they all left me. Yeah, I'm getting a little tired of this myself. Intersection point. We're going to abandon it. Even I'm abandoning 8764. So it was up. I should have just gone towards that range a little bit earlier. And this is futile. But if you're still here, good for you. Yeah, they're crossing right in there. And I can't get it. Seem to find it's going too small. Never mind. We're going with 8764 and calling it a day.